Okay, perfect. So I am gonna talk today about the next subject. It's gonna be a quick one. We're gonna talk about hexadecimal. So I'm gonna put this a little sideways on the tree because hexadecimal is very related to binary, but I think it's important to understand in general. So hexadecimal. Last time I talked, we were speaking about like binary. And we were talking about how binary is constructed and how you read it, right? And we said, just as a quick recap, that in order to read a binary, you start with one at the lowest digit, and then you multiply one by two to get two, and then four, then eight, and then you basically count the number of those things occurring. So the zero ones, there's one two, there's zero fours, and there's one eight, right? And if you add all of these together, equals 10, and that's exactly what this number is in binary. So this binary number here is 10 in decimal. Oops. 10 in decimal, right? Not super difficult to understand. Now the thing is that hexadecimal comes up a lot when you're coding, and it can confuse people. They don't really know what it is. They think it's like this new gibberish. But the only difference between binary, which is a base 2 representation of numbers, is that hexadecimal is base 16, right? And the reason and so if you've ever seen hexadecimal before, it will often look like this, something like A1F, right? This is a hexadecimal number, and that isn't an L. That's a one right there. And I think the thing that really confuses people when they first see this is that it has letters in it, and they're like, how can a number have letters in it? That makes absolutely no sense to me. But the thing is that it's because, um, as I was saying last video, when a number system is base 2, that means that it has two symbols to represent the various digits, right? So base 10, which is our number system, right, has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as the symbols. But base 16, you have this problem, right, where you get to the end of the numbers, the Roman numbers, I guess, or the Arabic number symbols, and you need more symbols because in order to represent base 16, you have to have 16 symbols. So what you do to solve this problem is you start to use letters: A, B, C, D, E, and F, right? And so what is happening here is that A is actually representing the 10th digit, B the 11th, C the 12th, right? And once you understand that, hexadecimal numbers are actually very simple to understand. They're not easy to read. Like I can't look at a hexadecimal number and just know what number it represents. But it's very easy to get to the point where you have the number. So if we take this number over here and we apply the same logic that we're applying to reading binary, because this is base 16, it means that the first digit here is going to be 16. The first digit there is going to be 1. It's always 1. The number of ones. The second digit here is going to be the number of 16s. Now, the third digit, and I'm going to have to do this on the calculator because I don't know the answer, is going to be the number of 16 times 16s. So 16 times 16 equals what? 256. Okay, I probably should have known that, actually. And so that's 256s. And then this one is going to be what? I'm not sure. I should definitely know this, but I do not. It's going to be the number of 4,960s. Okay? And so if I want to work out what this number is based on this knowledge, this information I've just noted down here, what I need to do is figure out how many ones there are. And since F, let's continue this over here a little bit, 12, 14, 15. Since F is 15, it's the 15th digit in my hexadecimal number digits. That means that there are 16 ones. So that's 16. 16 times 1 equals 16. How many 16s are there? Well, there's 1. So that's another 16 there. How many 256s are there? Well, A is the 10th digit. That means that there are 10 256s, which means we put 256. There are 2,560. That's 256 times 10. And there are 0 4,096s. So we do 0 like this. So if we add all this up, that's going to be 32 plus that. So that's 2592. This number here represents this decimal number there. Now, in this case, we have 4 digits in decimal and we have 4 digits in hex. But you can imagine if you put an F here, right? If we do another number and we just do F0000, that means that there are 0 1s plus 0 16s plus 0 256s, but there are 15 4,096. I'm just going to do that calculation on the side here. 15 times 4096, like so. So that's 61,440. So already you can see that F000, only 4 digits with a lot of zeros, is actually a friggin' massive number. So I'm bringing this up and taking the time to explain it because hex is used a lot throughout computer science and programming in general, and it does come up as like a representation sometimes. But at the end of the day, it's just like a compact way to write numbers as well that is on the same tracks as binary, but doesn't take as many digits to represent it, right? And one of the main reasons I'm bringing it up at all is because you're gonna see stuff like this sometimes. OX and then F1A01A, something like this, right? 2 5. This is a hexadecimal number. This is a convention in programming that means that everything that follows is hex. So this isn't part of the number. This is just telling you that it is a hexadecimal number. And then this is the hexadecimal number. And the place that this is seen is in memory addresses, which I will explain in another video. But in short, a memory address is where you put binary in storage inside your computer. So I'm going to stop there. This was a quicker one. Hexadecimal.